Hi everyone, myself Vignesh, currently pursuing BTech Triple at Dr. MGR Education Research Institute, Chennai. I done an internship in Emertxe on home automation based on Internet of Things. What we have learned from this Emertxe IoT online internship, basic C and C++ programming concept, how to install three tools for Windows Arduino IDE, Pixim Lab, virtual code installation process and environment setup. Basic of IoT and application, IoT devices and their working. Embedded systems, how to handle and run. Hardware like CLCD, sensors, etc. Implementation of IoT in daily life, working with latest technology software for microcontrollers and automation. Table of contents. These are the table of contents we covered in my PPT and we also seen in the IoT internship. C program started with introduction of the C programming, suggested with the IDEs, important characteristics of C program, data types and keywords, provided adequate resources, template codes, advanced C assignments, projects were provided. All these topics related to embedded C were covered. Topics covered in C, basic data types, operators, control statement, if else, cases, for loops, arrays, functions, pointers, strings, storage classes, preprocessing. These are covered in Emertxe IoT internship. Topics covered in C++. These are the topics. Embedded system. Any combination of hardware and software which is entered to do specific tasks can be called as an embedded system. Types of embedded system, standalone, real-time, networked, and mobile. Components of embedded systems. Actuators, sensors, auxiliary systems, ADC, human interfaces, diagnosis code, memory, ASCIIs, softwares. Introduction to Internet IoTs. Internet of Things is an ecosystem of a connected physical devices, objects that are accessible through the internet. IoT is a system of interrelated devices, digital products, objectives, people or animals that are provided with unique identifiers. It has the ability to transform data over a network without requiring any human interaction. The idea of blog post is to provide introduction to internet IoTs as well as expose reader with marketer potential, high-level architecture, and sample explain IoT uses classes for begin to get a practical and real perspective of IoT today. Components of IoT. First, IoT devices. Second, IoT gateway. Third, network. Fourth, cloud. Fifth is application. First, we see what is IoT devices. Using a sensors gather information from multiple sources. Second is a gateway. Integrate multiple IoT devices and collect data from them. Network. Centered around internet, all the information is exported to cloud. A platform that connected to internet and analyzes the data. Application of IoT. These are the applications where where we can see the IoTs are working and implemented. Industrials, automotives, smart homes, healthcare, retails, logistics, agriculture, education, smart cities, environments. Architecture's first principle addressing scaling, connectivity, data volume, sizes, cloud queues, cloud storage, and kits. This is the reference architecture. First, the device is connected with the IoT capable devices, existing IoTs, low power devices. This is the pathway which is connected to the gateway, then IoT solution backends, and then we present in the business connectivity like presentation area, UI, UX. Project agenda. Control garden lights on the basis of sunlight intensity. Lesser the sunlight, brighter the garden lights. Temperature control system. Switch heater and control on off remotely. Switch heater off automatically if the temperature indoors success 35 degrees Celsius. Water tank control. Switch inlet and outlet on off remotely. Switch inlet volume off automatically if the tank fills up. Switch inlet all on automatically if the tank volume drops below 2000 level. Project implementation. Garden lights LDR sensors. Temperature system LM35 sensors. Water tank serial communication portal. Microcontroller at Megatart 328p. Arduino board. Coding. Arduino IDE. Connectivity. Ethernet shield for mobile application remote. Blink IoT app. Simulation deployed using PixMLab LM garden lights. Light dependent resistor used to sense sunlight and send analog signal to microcontroller. Microcontroller adjusts brightness of a garden light, simulated as LED with respect to analog signal sent. Analog to digital conversion. It is used to read analog inputs. Only analog pins A0 to A5 connected to AD block. Arduino IDE. It's an interface we use software to coding. Arduino Integrated Development Environment software contains a text editor for writing a code, message area, a text console, toolbar with the buttons with the communication series menus. It connects the Arduino hardware to upload programs and communicate with them. Temperature sensor, LM35 sensor, an increase of 0.1 volt of every 1 degree Celsius rise to temperature. Hence, analog volt input divided to 0.1 to get temperature of room. The temperature and then displayed to the CLCD. Controlling heater and cooler remotely. Blink mobile IoT app. Using it W2T Ethernet shield, Arduino Uno is connected to the internet. Firmware configuration provided by Blink is used to connect to the Blink cloud. Blink mobile app is used to the user end-to-end connect to the microcontroller through the cloud. Data stream are created on Blink dashboard templates. These act as a virtual pins for exchange of data between mobile app and controller. Water tank, serial communication. Serial communication tank simulator used. Null emulator used to set up a serial communication between Pixel Lab and serial tank. COM6 or COM7, when in the real world things, we can use either any of the ports which we have already placed. RX pin of connected to TX pin, TX pin to the connected to RX pin of the microcontroller. To control inlet valve of the outlet part, send a byte code of either 0 hexadecimal to do this, and respectively followed by byte, and to disable. Serial write is a function for is to transmission of 1 byte at a time. 1x 30 byte is sent to request data from the volume sensor. It sends volume to 8 bits. Serial used to read those bits. Blinker. Virtual print used to display a volume of mobile app interface. In GAJAF to V4, V5 data streams used for transfer the data related to on off status of inlet outlet blocks. V7 pi used to send notification to terminal on app. Corresponding widgets created on developer mode in app. The microcontroller is programmed as to turn off the inlet valve if the tank is filled up inlet valve if the volume drops down to 2000 automatically. It's a corresponding notification regarding these events with the app too. Real-time volume of the water and on-off status of light and outlet valve is displayed on CLCDs. Now let's get into our project. This is LDR with high resistance. Now it's with high resistance. This is LED. Now it's glowing. During when we lower the resistance, LEDs reduces the light and stops glowing. Now you see that LEDs are off. It resembles daytime. When we reduces, when we increases the resistance, the LEDs starts glowing again. This is the first project. Next we see about the cooling and heating system. This is a blink cable we're using for the on and off of the heater and cooler. This is a CLCD where we shows the temperature and cooler on off. It's showing 25.7.4 degrees Celsius. Now we're gonna on the heater. Wait a second. Yeah, now we on the heater and it's slowly increasing the temperature to 32, 35. And when it reaches the 35 degree, it automatically cut off the heater and it shows the notification temperature is greater than 35 degrees Celsius, turning off the heater. Now it is a then we switch on the cooler. It slowly reduces the temperature to 77.9 degrees Celsius. It automatically cut off the cooler and it shows the notifications. Temperature is greater than 35 degrees Celsius. Turning off the heater, temperature is normal. Turn off the cooler. It shows like that. This is a heater cooler second project. Next we see about the tank uh, serial communication. Wait a minute. Yeah, this is the tank serial remote tank. It contains the 3000 liters of water. It connected with the COM port 1 and when you switch on it, it slowly reduces the tank. We can going to switch on it using a blinker. When it reaches the 1500 outlet, it currently cut off the outlet. When it reaches 1500, we'll see that, right? Yeah, 1900, 1800. When it reaches the 1500, it automatically cut off the outlet and start inletting the water. And it shows the notification water level is less than 1500. Water inflow enabled. So that now tank is increasing water by filling it up, and it cut off the outlet simultaneously. Now it's increasing slowly. When it reaches 3000, it automatically cut off the inlet of the water. You see that? Yeah, now it reaches 3000. Now it's automatically cut off the and it shows the notification is less than 1500, greater than, and it's closer 3000 and disabled. This is what our Emergze IoT internship on home automations. Thank you.